Our little kids do mathematics, and so I invited her to help out today, and she's going to share a few thoughts of some work that she's been doing around this topic. So thanks for being here today. And I'm from UC Davis, Rebecca Ambrose, and am working a lot with pre-service teachers these days, but my love is working with young children doing mathematics. And I'm going to share some interactions that I have captured on video. The kids you're going to see are not really representative of the state of California in the way that I would like them to be, but I had to use video that I had permission to share. So it's mostly my kid and a couple of other kids that I know well, but I think they do represent what you'd see typical kids from every ethnic group, every linguistic group in the state also doing. But we're going to start with actually seeing a Sesame Street video, if it'll run. This is Jesse Jackson, well, we'll just watch.
Here we go. I am somebody. I am somebody. I may be poor, but I am somebody. I may be young, but I am somebody. I may be on welfare, but I am somebody. I may be small, but I am somebody. I may make a mistake, but I am somebody. My clothes are different. My face is different. My hair is different. But I am somebody. I am black, brown, white. I speak a different language, but I must be respected, protected, never rejected. I am God's child. I am somebody. Give yourself a big hand.
Well, I forgot that when you try to stream a YouTube video, it doesn't project, but I got to see it. Hopefully, you'll take a moment to take a look at it when you get a chance. And you may be wondering, what is the connection between Jesse Jackson talking about I am somebody with a bunch of young children and what we're going to talk about today? One of them is that it gives me a model for doing a poem with you. We're going to do a call and response in the same way that Jesse Jackson just did with kids. So I'm going to ask that you give up some of your grown-up inhibitions and join me. I'll be leading the way. So, I am a mathematician.
I am a mathematician.
I have to take my glasses off. I like numbers. I like shapes. I like patterns. I am a mathematician. I like to measure. I like to sort. I love problems. I am a mathematician. I wonder. I figure things out. I make mistakes. I try again. I am a mathematician. Well, thank you for indulging me. The association between this poem and the poem that we heard from Jesse Jackson is that I think that they both give the message that everybody's important. In our case, everyone can do math, and it's not just the purview of an elite few. Doing math is empowering because it enables the individual to take control of all aspects of their life and not be dependent on other people. Unfortunately, in our culture, we tend to privilege math for just a few, and by doing that, we rob people of the opportunity to feel like they are masters and they can do things for themselves. That is the case in other cultures, and I think that we could make a really important first step with children by not only encouraging them to think of themselves as mathematicians, but talking about yourself as a mathematician as well. We all do math, and math is around us all the time. And figuring out things for oneself can promote a sense of agency and mastery. And I'm sure you've seen it when children all of a sudden can do something for themselves, how proud they are, and how they feel like they're gaining a control of their environment. And we want them to have that feeling all the time. And I believe that using mathematical language engenders respect and demonstrates membership in the mathematical community. So when you are able to help a child develop some of that mathematical vocabulary, when they go into the next classroom, their teacher's going to go, whoa, this kid knows some math. And that will engender continued disposition towards seeing oneself as a mathematician. And in fact, I use that a lot. When I'm trying to teach children about some vocabulary, I'll say, mathematicians say, and then they start seeing themselves as a member of that mathematician community. So today we're going to talk about some math moments, and these are different situations that lead to mathematical activity. And I'm hoping to share with you some thoughts about tools and environments that can support mathematical thinking. I think the previous session in here did some of that as well. And give you some examples of talk that supports math learning. So why is informal mathematical activity important for young children? There was a study done recently of what parents reported doing with their children, and there was a huge variability in what parents were reporting about the kinds of things they did with kids. And this researcher was particularly interested in indirect activities, so those are things like board games and shopping and cooking. And he found that those activities were significantly related to later performance in mathematics. And in general, parents reported reading more with their children than doing these other math-related activities. So I think that we've done a really good job of getting the message out to parents that they need to read with their children. Now we need to get an equivalent message out about doing math with kids. But that doesn't necessarily mean sitting down and doing math worksheets. It can be part of everyday activity if the adult knows what to look for. And Alison Gopnik is a professor at University of California, Berkeley, and she's done a lot of work with young children, I mean, really babies. And she says that children have amazing cognitive skills even when they're 2, 3, and 4. They're exercising those cognitive skills in the course of playing, of experimenting, of exploring. And when we make preschools more academic, more structured, more like schools, we're actually not encouraging children to do the kind of real deep scientific and cognitive work that they're capable of doing when they're exploring with a knowledgeable and attentive person around paying attention to them. So I don't want to necessarily set up a dichotomy between sort of the organized structure academic activity that does promote math learning, but I also want to draw attention to a lot of the informal activity that can also lead to math learning. But I also want to point out that it's challenging being that knowledgeable, attentive person that she mentioned, because it requires you as the adult to see the math in the situation, to elicit the thinking from the child, to bring language to the situation, and to keep it playful. And this is something you'll see in a couple of the videos that I struggle with, is when I come in with my math thing, sometimes I push it too hard and the kid walks away. So I like to think of this as voice and choice, where I'm trying to keep as much choice for the child in interacting, and also bring voice to those interactions so they start learning the terminology that goes with mathematics, while keeping it playful and fun, and also recognizing that the attention span of young children varies a lot. Sometimes they'll spend many minutes doing something that seems like they'd give up on really quickly, and other times something you think is going to be really engaging ends up not being of much interest to them at all. So sensitivity to that attention, I think, is really important. So just to reemphasize the importance of math talk, Another study found that the amount of teachers talk about math was significantly related to growth of preschoolers' math skills over that school year. And this was following teachers around during their morning meeting, I think it was, to see how much mathematical language was being used during that time. And again, it was widely variable from classroom to classroom how much math talk they were hearing from the adult. So I'm prepared to talk about all these different kinds of activities that are considered mathematical and to provide you some examples of these. And hopefully we'll get through most of them. But we'll start with the one that's probably most familiar to all of us for young children, and that is sorting and categorizing. And these are some photos of matching socks is probably the most common activity in a lot of households. But again, bringing language to that and even just talking about the idea of match and pair and then counting those pairs. You remember that little boy that we saw earlier today who treated those 2 crayons as a unit and said, oh, I have how many groups? And then he said, how many crayons? That's actually quite significant. And so getting kids to talk about, oh, there's 5 pairs of socks and there are 10 socks. They're now paying attention to the unit. And that is actually a very important thing that is not trivial. And yet if you just start incorporating that into the day-to-day, the kids will hopefully adopt it when they're ready. And then sorting out the silverware is another daily activity, and again, talking about it while the child is doing it. Both of these children are probably have a limited vocabulary as approximate 2-year-olds. So whoever the grown-up is might talk to them about, oh, you're putting all the forks into one group, using that word group or set, and also maybe drawing their attention to, oh, those are forks because they have tines, so that the child is also beginning to realize that we have attributes that we use when we sort. And this work of classification of grouping objects according to their attributes is what we basically are doing in geometry. So when kids are learning about different shapes, they learn to make those distinctions between shapes visually, and they know what rectangles look like. But if we can also draw their attention to what are those attributes that make these things rectangles, that's the next step in their thinking that we would expect in 1st and 2nd grade. And statistical thinking as well is rooted in this work of categorizing things, where questions like what kind of pet would we probably find if we went to the home of a child in our class, that's depending on us first classifying the children according to their pets. So I'm going to share with you an example of some parallel play. This, I have to acknowledge, this is a little bit of a clinical environment because this is the daughter of a friend of mine joining me in my office. But I didn't really have a planned out, okay, first we're going to do this activity, then we're going to do this activity. I just pulled out these beads, and she and I started fooling around with the beads. And this is to just give you an idea of the kind of conversation we were having.
cylinders and spheres and cubes in yours too? There's lots of different kinds. Maybe we can count up how many kinds of beads there are. Do they? And what's in the book of shapes? Each color has 3 kinds of shapes. A cube, a cylinder, and a sphere. So let's see, which ones am I missing? Do I have the yellow? Do I have the yellow cylinder? That's the yellow cylinder. Do I have the yellow cube? And do I have the yellow sphere? All right, so I have all the yellow ones. How about red? What am I missing? The cube. Okay, should I put it on there? Check for me and see. Whoops. Okay, do I have all the green kinds? What am I missing? Okay, can you find the green cylinders for me? Oh, thank you. Now I'll put those on. I kind of like 2 of each. I could have put 1 of each, couldn't I? All right.
All right. So what do folks observe, or any comments that you might have about that interaction? Hold on, we need to get you on the mic.
I think it was interesting that she first said that she had the book at her school that was full of shapes, and she was pointing them out, but she wasn't naming anything.
Mm-hmm.
And then you introduced some of the vocabulary, and then later on, she's using that vocabulary. So it was a very gentle, kind of natural way to help her start using some of that academic vocabulary.
Mm-hmm. And it seems like she was
You.
familiar with it, but
Yeah.
just not at that productive stage right away. Any other thoughts or observations people wanted to share? Yes.
I was just going to comment similarly that she drew on her own experience, which I thought was really neat. I thought, oh, that's what she knows about shapes. And then also that you were introducing the 3-dimensional shapes, which commonly in early childhood education we focus on like the basic shapes and not as much 3-dimensional, and I really like to see some of that.
Mm-hmm. And it just so happens that the beads that I have with me today had those attributes with them, so that made it really natural for that to come up. So let's see what I wanted to say about these. So we're both doing our own thing with the necklaces, and we made it a language-rich interaction. You might have noticed that I asked her to count my necklace, and she didn't want to, so I had to let that one go. And as was noted, I introduced the categories of sphere, cube, and cylinder, and then she made it clear she was familiar with those terms and had learned them at school. And then we talked a little bit about the pattern where I had 3 types of beads for each color, and my necklace had 2 of each kind of shape. And I have to also admit that these were ideal conditions in that that environment didn't have a lot of other stuff there to distract her attention, although you heard her baby brother was there making some noises, and that didn't disturb her. So this is my daughter doing some math with her dad. She's now 20 years old, and she saw me watching a lot of video of children doing math. So she thought that was a great way to get mommy's attention, and this was a time I wasn't even at home, but she requested to make a math video. And this is the beginning of the interaction.
For our math puzzle, what do you have? How many do you have? Quite a bit is right. You emptied out all 4. You think those castles will fit in the cube?
He's a fast worker.
How many purple ones does it take to make a square castle with a point? How many green ones does it take to make a square castle with a point? How many blue ones does it take to make a square castle with a point? Is that a square castle with a point? I wonder if we can make a different square castle. If you put 4 blue ones together, does that make sense? Like a square castle? Try 4 ones. I want to see what that looks like.
All right. Any observations or comments about those interactions? By the way, these are they make cubes, all those shapes that she decided to dump out on the table. Yes.
What I noticed was when she was doing it herself, she was very engaged and was making up her own story and was very happy. And once he decided to ask her a couple questions, she did a couple, and then she made sure it didn't work. You know, oh, well, it's not, I did 2, and they were, nah, it's not working anymore, Dad. Like, I'm done with you, your question. You know?
Well, so we see that sort of sense of mastery, especially when she started making her square castles, and that was very much her own idea. I also thought it was interesting how she brought that little gnome thing into the square castles, which I think was referred to earlier when Megan Frankie was talking about kids wanting to make up stories about things. So combining the sort of math with the more imaginative play, I think, is interesting as well. So this puzzle is not meant to be a sorting toy, and she decided to do that herself. And she was sorting by both the shape and the color, as we saw, and then putting them together to make a square castle. So that was a place where, if I had been there, I would have said, oh, you're making a square pyramid, to just introduce more of the math vocabulary for her. But she was putting them into groups herself, so we, again, are seeing that grouping thing that we definitely want to be promoting. She did take up her dad's bid to make the specific square castles, but as we already noticed, she exerted her own choice by giving up on that 4. The 4 blue ones do make a square pyramid. So just a quickie to show that even the really little ones using a sorting tool that
All right, you put the circle in. You put the square in. All right. And that's the hard one, that's the pentagon. Try the circle. you find the holes that those shapes go into? Okay, you start with the cross. Okay, found the hole right away for that one. What shape is that? Can you hold up that shape? That's the triangle. Okay. Let's see. I can't see the hole. Is it working? No? Can you find another hole you might go into? Oh, I think you might have been trying the right hole. You just had trouble getting it set up properly.
So I'll just go through the comments on this one really quickly. That first sorter only has 6 shapes, so he had an easier time with that 6-shape sorter. And he was choosing the right holes for the second one, but it was more difficult for him to get the hole in the toy in the hole. Part of what's going on there with the thinking is he's having to do some spatial relational thinking. There's a lot of research to support that experience in doing that promotes learning, although we don't do very much of it in school, and we don't do very much of it at all K-6. Although those spatial relational thinking skills are very important for fields such as engineering, architecture, and other science areas, so giving kids those early childhood experiences may be all they get. So you're doing a really important job when you're exposing kids to activities like the shape sorter. And you notice that I was narrating the whole time, especially around what shape he was using. He had very few words at that point in time. And as I said earlier, the spatial thinking is associated with future STEM performance. And just to show you what this leads to, this is a tool called Polydrons. I'd highly recommend them. I didn't bring mine today. But this is a first grade class where the children have had a free choice in what they make with the Polydrons. And then they, as a class, sorted out what they made. And this particular tool can make very complex structures, and they're using that same kind of thinking of what are the attributes that these things have in common. So that sorting work that they're doing early on pays off later. So we learned a lot about quantifying this morning, so I'm going to go through this fairly quickly, but one thing that I wanted to point out was that as one of the speakers this morning said, we are hardwired to count and quantify. And many other animals have the ability to not necessarily name the amount, but to keep track of magnitude. So there have been some studies to show that lions judge the size of another pride, and then they decide whether they're more or less than they have in their own group and decide if they should attack the other pride. Fish, believe it or not, can distinguish between the size of different shoals, and they go and swim with the larger one. Spiders can keep track of how many prey they have in their web, and crows can also keep track of counts up to 16. So when we ask kids to count things or quantify things, we're building on some really innate abilities that they have. So I'm going to let Chelsea talk a little bit about this organizing walnuts activity that she did with her son.
So thanks. This is my son and a friend, and I know as educators we think a lot about the tools that we give kids and the tools that we add to their environment and how do they use them. And so I know that they're developing one-to-one correspondence, and I was curious if asking them to count the walnuts and putting them into something if they would use one-to-one correspondence in that setting. Actually, I was going to say one more thing. Working with 6- and 7-year-olds, egg cartons are another tool that I like to put in the environment there with counting collections. And the prompt in that situation was how can we count in systematic ways? So in that situation, I didn't tell the kids to use the egg cartons. They had egg cartons. They had paper cups. They had like embroidery hoops, and not everyone, of course, but a couple of children chose to use egg cartons and put them in there, and then used it to think about it in grouping. And so they were generating that idea of using it as a strategic tool for grouping. Oh, another thing I did is I was curious about, I know as educators we're always thinking about the language that we use in situations to engage children mathematically. And I was curious how parents saw their children engaging in math activities at home. And so this is one that a parent shared with me, and their daughter was setting the table on just an ordinary activity that we could all do with our kids, but she decided she was making a pattern with cups and plates. And also setting the table is an activity where we can ask like how many plates do we need, and kids might start thinking about how many people are coming for dinner, and so then it's also a quantifying activity if we add that language to it. I think that's it.
All right, so we're going to
We're going to take a look at Audrey again, and this time she's invited to count all the beads that I have put on my necklace.
I don't think it's 88. Why don't you start counting from here? Why don't you count from here, Audrey, then you can slide it.
1.
Okay, you want to slide it? Okay, go ahead.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 100.
You know what you just did? It went 99, 100.
Well, I don't know.
Yeah, 29. Your mom told me sometimes it's hard to remember. 29, 30.
29. She was very, very emphatic about that 100. So questions or comments about that one?
I'm actually kind of curious to know what she said right after you said the 20. You corrected her and said 30. Did she react to that? Do you remember?
No, I don't remember. I just edited this clip. I don't think it was anything too momentous.
Okay. I did just to see what her reaction would be from that, like, because it's always like going back and forth on correcting them. In what moment do you correct them? How to correct them appropriately without stumping their excitement or understanding or exploration of it too. And then I liked how she said it's about up to 88, I think she said. And the fact that she kind of was estimating too, like about, and she knew that she was kind of guessing and predicting the amount and that she didn't know. And then I like how you added the sliding feature, like gave her something to do while doing it. Like earlier they were saying the teddy bears, that some children need to stack things as they're counting it or kind of emotion with it. So I think that really also helped her in that process.
Any other questions or comments? Let's see. You did notice that I said your mom said you had trouble with that one. So, and I'm sure many of you have observed that. There's like a limit that kids get to, and sometimes it's because they've been counting a lot but not often above that number. And it's always fun when they say 29, 2010, 2011. And so they just, as Megan Franke said earlier, they need to learn that sequence. It's not something they're going to make up out of their heads. So as we mentioned, she's still working on estimating the magnitude for those large quantities, but she has pretty good one-to-one correspondence, and she knows the number word sequence very well up to 29. And she was responsive to that bid to count that particular time that I gave it to her. So I want to show you another counting collections that came up in just sort of everyday activity. We happened to be in Hawaii. It was my last time there 19 years ago. And these nuts were all over the beach, and to keep the girls busy, we invited them to count all the nuts they'd collected. So they'd collected a whole bag full of nuts. And they're on the balcony here, and they decided they would count them by 2. And you can see the long, long row of 2 that they made. And they spent about an hour organizing those nuts to count them. But in the end, they had trouble, not surprisingly, because they kept losing track of their counts. And they kept going back to rearrange the nuts. But it was great for the parents because they stayed busy out there talking to each other. So I think they may have learned from that lesson that when you have a huge, I don't think they'd ever had to count that many things before. And so they decided that they'd be better off counting it a different way. So on another day, I think I suggested let's make groups of 10 so we can count those nuts. And so Arden got lots of practice making same-size groups that day and counting to 10 with the cardinality for 10. And so now I'd like you to talk at your tables for a minute about what you do to get Arden talking about what she's done. So whether you'd make an observation or whether you would ask her some questions. Okay, I'm going to interrupt, and I'm hearing lots of good ideas out there. Anybody want to share one of their thoughts about what we could talk to Arden about this arrangement? Get out of your comfort zone. Hold on, here's the mic.
Groups may not have 10 in it, and that's why it's in a line, because it's not. And so I would probably ask what's going on with this group, and if it was, oh, well, there's not enough to make it 10, the question, well, how many more would you need to make that 10? Might be a good question to ask.
All right. Other ideas? Yes.
I might ask, how could you organize these so that they're equal groups, and see if maybe they went back and reorganized.
Are there some that are not equal up there? Oh, the one that's on the edge. So yeah, so the question, are they all equal, might also invite some conversation about the ones on the edge. Another question or a comment?
I was just curious because she seemed to have clumped them in 10s for a reason, and I in my classroom it would be because of prior experience, because we often put things in groups of 10 to count. So I might ask her to, if she was going to count, if she counted those, would there be an easy way to count them? I mean, how old is Arden?
She's 5.
Yeah, so she probably has the ability to count by 10s. So it'd be interesting to see if she chose to count by 10s, or if she counted each group one by one. Or first you ask her how many groups there were. If she could count the groups, because that's a little bit smaller number. But I mean, there's so many things you could talk. You could even ask her, because they look to be. Are they acorns?
They're these. I think they're kukui nuts that are about this big that you find on the beach.
Because you might even could ask her to categorize them in another way. Now, she did them by 10s. Could she look at an attribute and sort them by an attribute rather than just by a number? I mean, there's so many possibilities, and it's such a simple material.
Right. Yes. Leah.
What I thought was really cool was that they had the opportunity to revisit the counting activity again. The first day they made the line, but then they were still interested in playing with them. It kind of reinforces that notion, like, don't just give them something once. When they were exposed to it the second time, you were able to pose a question, to give them the opportunity to make the groups, to continue building on that experience with this real-life material that they had discovered, just in their own natural environment while they're on vacation.
I'm curious as to whether you, or whether or not the girls were able to reflect on which was easier or which made more sense. So the first time it took an hour, they had a lot of trouble, they had to go back, and then realizing that the second time around grouping them into 10s is much more efficient, and how they could apply that strategy to other activities or other problems that they have.
Well, I hope so. It was a while back, so I don't remember the particulars, but certainly seeing it this way would be helpful. So I just wanted to emphasize the importance of grouping, and I don't know if you're familiar with Constance Camille, Kamii, but this is a diagram for her where she's trying to capture how, for base 10 thinking in particular, this group of 10 is not something that kids get very quickly, and when we don't give them lots of opportunities like Arden had, sometimes they haven't constructed that that's one group and it has 10 things in it. To think in that two-dimensional way where it's two things at once, it's 10 ones and 1 10, is actually kind of a cognitive advance that some kids make sooner than others. And we often underestimate that it does represent a cognitive advance. So when we see kids naturally grouping, it's a really good idea to have them count how many groups do you have and how many items do you have. So they're starting to think, oh, I have 5 groups of 10 and I have 50 items, so that they are doing that kind of simultaneous thinking. And that's really at the heart of multiplicative thinking and is what's behind the base 10 number system. So here's another math in the moment. When we were camping as a family with another family, there were 10 of us, and there was a 5-year-old boy there. And so as we were putting up the tents, we said, well, 5 people can fit in this tent. How many people are going to have to go in the other tent? And so here is Jacob thinking about that problem. And here he is putting up 5 of his fingers. And here he is finishing off the problem. So let me tell you what I think he was doing. He was obviously using his fingers, and just as, whoops, skip the ad. This is an article, a very recent article about why kids should use their fingers in math class. And it's a Joe Bowler article for those of you who are familiar with her. And it points out how this can form the basis of a lot of mathematical thinking, and unfortunately a lot of people, especially parents, will discourage finger use. And these are the world's first manipulatives. They're organized in tens for us. And if kids can get facile with their fingers, it can really be helpful to them later on. In my experience, when kids have been discouraged from using their fingers, they actually tend to use them more. They just put them under the table. And if instead you ask them to articulate what they're doing with their fingers, then they can start to abstract what they're doing with their fingers. And I'll tell you a really quick story about Arden. I was starting to doubt she was going to get to that abstract place because it seemed like she was using her fingers forever. And then one day I gave her the problem, what's 7 plus 8? And she said 15 pretty quickly. And I said, well, how did you get that? And she said, well, 5 and 5 and 5 is 15. I said, I didn't give you a problem about 5s. I said, what is 7 plus 8? And she said, yeah, it's 15 because 7 is 5 and 2, and 8 is 5 and 3, and 2 and 3 is 5, so it's 5 and 5 and 5. And she was holding up her hands when she did that to make it really clear why she was breaking 7 into 5 and 2 and 8 into 5 and 3. And I would not have anticipated that strategy, but it showed that work with her fingers actually was something she finally internalized. Jacob started with 5 on the problem about the tent, and he counted up from those 5 up to 10. And so for Jacob, that problem, which to some grown-ups might have been a subtraction problem because you have 10 people and 5 of them fit in the first tent, he did not treat it that way. He treated it as an adding up to problem because there was no real obvious action in that problem. You could treat it either way. And so one lesson that I think is really important about working with kids is you do not impose strategies on them, especially when they can figure it out for themselves. And they'll often figure it out in a way that you don't necessarily anticipate, so you need to be paying close attention to what they're doing, so you're not imposing your thinking on them, but you're just supporting their thinking. So to make that point again about fingers, let's watch see Lolly. Now this is in school, and this is her teacher talking to her. She's been asked to solve the problem. Miguel has 13 cookies. He gave 6 of them to his friend Robert. How many cookies does Miguel have now? Let's see. There we go.
Miguel has 13 cookies, and he gave 6 of them to his friend Robert. How many cookies does Miguel have now? Miguel has 13 cookies. He gives 6 to his friend Robert. How many cookies does Miguel have now?
7.
Okay, can you explain how you figured that out?
Because 13, I know that 10 plus 3 is 13, and I take the 13, the 3 away, and the 3, and that equals 7.
How did you get the 3 to equal 7? Where did the other, how did you get to 7 from 3?
Because when I get to 13, I take away the first 3, and then the other 3, and that equals 7.
Okay, nice job, said Molly.
All right, any quick questions or comments about that one? You'll notice that she didn't use her fingers to get the answer. She had that answer immediately, but she explained using her fingers, which suggests she's thinking about 6 by referring back to her fingers.
Would you call the 10 like a benchmark, or kind of like go to the benchmark number where kids move back to that point and then?
Certainly some kids do, and some curriculums sort of support that, and we're seeing evidence of it here. But that's a strategy that comes pretty naturally to a lot of children. I think we're supposed to be ending, but I want to show you one more math in the moment that was really recent. I was at a party, I saw this little boy, and I asked him about his sister. His sister was right there. She was 3 and would be turning 4 in August. And Oliver's 6, so the classic question is, how much older are you than your sister? But what he does here is a little bit interesting.
So Hannah, she's 3 years old, and I'm 3 more older, and she has half of this finger because she's 3 and a half. But she's, I think, a tiny bit, just a tiny bit more. So she takes just a tiny bit more space of this finger.
So how much old?
This whole finger is 4.
So how much older are you than your sister?
3 and a half.
3 and a half what? 3 and a half yards, 3 and a half feet, 3 and a half pounds.
I don't know.
You're not sure. Okay, 3 and a half somethings. Yeah, okay. You want me to tell you?
No.
All right, we lost our...
Whoops. So I just wanted to close with that, which is that if I had that to do over again, I would have tried to ask him a lot more about what he was doing there with the fraction on his finger, instead of saying, oh, kids often don't know that it's years that they're counting. So trying to give voice and choice is tricky business, but I hope that you'll go out and do that, and happy to answer questions out in the hallway. But thanks again for coming today.